Okay, so what if I told you that we could travel back in time, but instead of a time machine, we're going to use a giant drill, and we're going to the coldest place on Earth. Today, we're on an incredible scientific adventure to Antarctica to uncover a frozen archive of our planet's history, a story told by tiny bubbles trapped in ancient ice. You hear that? That's the sound of pure scientific joy. That's a scientist, after years and years of planning and unbelievably hard work, finally holding a piece of the past. And this isn't just any old ice, no way. It's a time capsule, and what's locked inside has the power to tell us where our planet has been and maybe where it's headed. So the big question is, how on Earth is it even possible to get a direct record of Earth's atmosphere from a million years ago, right? I mean, the answer isn't in some dusty old book or a fossil. It's frozen solid, just waiting for us nearly 3 kilometers underneath the Antarctic ice sheet. So our story really starts with the hunt itself. And look, this is not your average field trip. We're talking about one of the most ambitious scientific expeditions of our time, pushing people and their technology to the absolute limit in the most extreme environment you can imagine. This is the Million-Year Ice Core Project. Their goal is pretty straightforward, but absolutely massive. Drill 3 kilometers deep to find the oldest continuous ice core ever recorded. This meant an epic 1,200-kilometer journey across the frozen continent just to set up camp. After years of work, they just recently drilled their first core. And that feeling of finally holding it, as one scientist put it, it was a real joy. But why? Why go through all that trouble for a cylinder of ice? Well, because each and every layer is like a perfectly preserved page from Earth's climate history. It is, literally, a frozen time capsule. The basic idea here is actually super simple. Think about a layered slushy drink. If you stick a straw all the way in and pull it back out, you get a perfect cross-section of all the different flavors. An ice core works exactly the same way, but instead of flavors, the layers represent years, centuries, and even millennia. So here's the play-by-play. Every year, snow falls. Over hundreds and thousands of years, the weight of all that new snow just squishes the older layers down, turning fluffy powder into this dense material they call fern. And as it gets squeezed even more, it becomes solid ice. And here's the magic part. It traps tiny pockets of the atmosphere from that exact moment in time as little air bubbles. And those bubbles, man, they are the jackpot. They are a direct sample of Earth's ancient atmosphere, with greenhouse gases like CO2 and methane inside. But that's not all. The ice also traps everything else that was floating around back then. Volcanic ash, dust from ancient deserts, pollen, smoke from wildfires, and yeah, in the more recent layers, even microplastics. It's an unbelievably rich archive.
Okay, so you've got this frozen cylinder. How in the world does that become a detailed climate record? Well, this is where scientists use some seriously clever chemistry to read the stories locked inside.
The secret sauce here is a concept called a proxy. You see, since we didn't exactly have thermometers a million years ago, scientists use these preserved physical characteristics, like the chemical makeup of the ice, to stand in for direct measurements. It's kind of like using tree rings to figure out a tree's age. And one of the most powerful proxies is the oxygen thermometer. It's genius. So water is H2O, but not all oxygen atoms are the same. You've got a light version and a heavy version. The heavy kind is, well, heavier, so it's harder to evaporate from the ocean and it falls out as rain or snow more quickly. That means the colder it is, the less heavy oxygen makes it all the way to the poles. So, by measuring the ratio of heavy to light oxygen in the ice, scientists can calculate the temperature of the planet when that snow fell. It's amazing. But here's what's really incredible. When it comes to greenhouse gases, they don't even need a proxy. Remember those bubbles? They're not a clue. They are the real thing. A direct physical sample of Earth's past atmosphere. Scientists can literally release that ancient air and measure its composition directly. It's like having a library of air from throughout history.
So we have the method, we have the data. What does this unparalleled record of our planet's climate actually tell us? Well, the story it tells is crystal clear, and it's a stark one.
For at least the last 800,000 years, through multiple ice ages and warm periods, atmospheric carbon dioxide naturally fluctuated within a very, very consistent range. It never went below about 180 parts per million, or ppm, and it never went above 300 ppm. That was the planet's natural rhythm. And this is the concentration of carbon dioxide in our atmosphere today. For the first time in at least 800,000 years, and likely much, much longer, we are far, far outside that natural range. I mean, this really puts it all into perspective. For hundreds of thousands of years, the absolute ceiling for CO2 was 300 parts per million. Today, we haven't just broken that ceiling, we have completely shattered it. We're in uncharted territory. Now, this isn't just an interesting history lesson. This ancient ice provides the critical context we need to understand our present moment and just how unprecedented it really is.
Why should we care about numbers from tens of thousands of years ago? Because they reveal the very foundation upon which our entire world is built.
About 11,000 years ago, after the last ice age, the Earth's climate settled into this period of just remarkable stability. It was in that calm, stable window that everything we call human civilization happened. We invented agriculture, we developed writing, we built our first cities, all of it. For thousands and thousands of years, we've had this incredible gift of a predictable, stable climate. It was the reliable stage on which the entire story of human history has played out. The ice cores prove this, and they also prove that we are now actively and very rapidly changing the script. The ancient ice has given us the baseline. It's shown us what normal looks like, and it shows us just how far from normal we are today. All of our civilization was built during one long, calm climate summer. The question this ice forces us to ask is a profound one. What happens next, now that we're pushing our planet into a new and much less stable reality?